When you do a regular bridge inspection, you need some kind of platform or movable equipment, ladders and so on, which is very complicated and expensive. The revolutionary thought is that with drones you can fly into a narrow space and determine, yes, this is where parts of fixings are falling out. This is where a connection is loose. Damaged drainage, damage to paint and concrete. And it is very fast and effective. We will fly about a meter from the rafters with the camera up.
In Lochkov in Prague, we deployed the Elios anti-collision drone and the Mattress M210 autonomous plane, and we were working on a project for the Department of Transport where we were looking for uses for this equipment. With the anti-collision drone, we were able to get very close to the construction. We were able to get close to individual cracks in the structure.
Flying makes the inspection very fast. We can roll right on the structure, spot issues where they may be.
The second drone has a camera with a 30 times optical zoom, and we are able to spot details from farther away too.
We'll fly closer, zoom in and measure the cracks. Look, here are the issues. Let's make it larger so I can see what type of issue.
We were the first to be able to legally get to a bridge of this type with a drone. It wasn't easy. We had to check with 7 different organizations which make decisions about whether something like this can be done here. It took more than a year and a half to get the permit to do it. The typical process is that a crane is rented and secured on the top of the bridge. Then using a U-shaped device, the technicians can get underneath the bridge. Of course, that requires blocking off one side of the road on the bridge.
When one of the lanes on the bridge is closed, it is very dangerous if a truck hits it. This has happened before in another country. We used to rent a lift from Germany and the daily cost was about 80,000 Czech crowns, and the inspection lasted 4 to 5 days. Today, the Department of Transportation has the lift, but it isn't free to operate. We are able to do the inspection in 1 day. Then you look through the footage for 2 to 3 days at home, warm and comfortable, and your findings are made into a full documentary that can even be forwarded straight to the court in the case of suspected bridge failure. You can always return to the evidence, so it is not based on the subjective opinion of an inspector. This crack, yes. Let's take a picture. On this particular bridge, we found that there was seepage through a failure in the insulation system. There were too many cracks. This big gap, you see it? Well, the second half is considerably worse. There are considerably large temperature differences. When the bridge is heated, it moves sideways up to half a meter, and that can cause such failures. We are within the warranty period, so that means that inspections should be made annually. Every year the conditions should be determined and the warranty applied and mistakes fixed. And since it is so fast, I'd even take the outside so we have both. The point is that we know the abilities of this unique technology so we can get the most information out of it. Now we are actually debating another technology, a scanner drone, which allows spatial modelling in 3D, which will be used for bridge evidence and refurbishment planning at a 21st century level.